I'm Sam Bishop, as Tom was just saying. I'm a freelance software developer and consultant, which is how I've wound up doing an astonishing variety of things, including most recently adding space robots to that list as a company I just started. My contact detail is on that slide there. But today I'm talking about Kubernetes. So I'm going to cover some Kubernetes basics here, because not everyone has used Kubernetes, has any familiarity with what's under the hood, even if they have used it. And generally, it's important to sort of have at least an idea what bit things that we're about to talk about actually interact with, because that will make some of the concepts fit together better. And on the topic of concepts, I'm probably going to interchangeably use the words pod and container. I know they aren't the same thing, but when you shuffle containers and Docker containers around so often that it just starts to become, I'm moving the container, it becomes really easy to forget that you're talking about a pod. Pods are the actual unit of deployment inside Kubernetes. Almost everything at the end of the day becomes a pod one way or the other. So they're kind of interchangeable, but not technically interchangeable, but fundamentally the same thing, really. There's just too many ways to stuff it up. So with the number of pieces in Kubernetes, I've decided to zoom out to about 10,000 feet and just sort of look at the big ones. So realistically, all of these things here are in most Kubernetes clusters. A couple of these are optional. So if you aren't running it on like an Amazon or an Azure or a Google Cloud, you won't have a cloud controller manager because you're not dealing with a vendor whose API you need to talk to. If you aren't running it in a more full setup, you may actually not have a DNS. If you're running sort of an embedded environment like a K3S, you might not have a cluster DNS. Or if you run your own sort of hard, sort of locked down DNS, you may actually have a custom thing dealing with the DNS. So that's, again, it's optional. But the main pieces that you have to keep everything working together and all the gears meshed is the controller manager, the scheduler, the API server, some kind of a database, which 99% of the time is etcd, and then on the workers that actually have the pods and the containers where all of the work actually happens is you've got your proxy, your kubelet, and some kind of container runtime, be it Docker or CRIO or a few of the others that are starting to come available now. But most of those aren't relevant to this. It's just the API server, and to an extent etcd, because when we make a controller, we're making something like that piece up in the top left there. That piece in the top left only really talks to API server, and any other interaction it has with the rest of Kubernetes is mediated by that API server. So I'm going to focus in on that and get a bit more context on this, because some of these steps are relevant to building a controller. So when you send a request into the API server, it does some basic handling, just like any good web API would. It is a HTTP API, so you could actually build a controller with curl, and I've seen some bash scripts that do. But you do some authentication, some authorization, make sure that you're allowed to actually talk to the Kubernetes cluster admin APIs, and then what it'll do is it'll do a mutation admission. It'll go, has something said, I need to get in the way of this. And there's a special set of hooks you can add that turn that on and off. If you've registered that, your controller can actually mess with things. So if you wanted to, you could write a little controller that says, I want to put foobar on every single container that gets put into Kubernetes. And every time one goes through this mutation, your little controller would get called and it would go, yes, I'm going to mess with this and put my data in here. And then it would proceed just like it would normally. So that's that stage there where you've got a hook that you can attach to. Then it does some validation to make sure you haven't actually stuffed things up when you made the changes. And then after that, it's got the validation admission where it makes sure that it's definitely okay with that. Because if you were doing a security controller and you wanted to make sure that someone hasn't deployed an insecure version of a software package, you'd want to validate that there. You might be looking at the versions of the containers that are deployed, looking at your software management system and going, is this a version of a container where the SDLC has not been checked properly? And that maybe we have an insecure version of Node in this package, or an insecure Python library, or an insecure whatever else you're deploying. And you'd use that last hook there, that validation admission hook, to get in the way at the last step and check. But once something gets through all of these on the way in, you get access to etcd, the data is written, and then that can just be read cleanly back out by anyone with read permissions on those read calls. But when it's getting written, it gets written into the API server's database, which is, as I said, 99% of the time it's etcd, which is just a key value store. It's really straightforward. It's designed to be fast, simple, and distributed. And so when it's actually storing this, it just stores this data under a path like that, literally like the paths you see there. And with those paths, you just get the JSON data stored, the actual object data at the end there. And then the Kube API server gives you an interface you can watch. So you can effectively think of it kind of like PubSub in a way where you can ask it, hey, send me changes, and it will just stream those back to you whenever one appears, which is one of those fundamental blocks that controllers get made out of. And on that point, controllers and operators are kind of a squares and rectangles thing. They are extremely similar in that almost every single operator you come across, basically all of them, is actually a controller, but not all controllers are operators. But they are fundamentally doing the same thing, which is why I'm going to kind of cover them in parallel. So if you build a controller, what you're fundamentally building is you're building a reconciliation loop. What you're doing is you're writing a little piece of software that says, hey, every so often check that the world is the right way. Or whenever something triggers it, if it's hooked up to one of those incoming loops, it's going to go, okay, I've been told things changed. What am I supposed to do about that? And then it will make the changes to things either outside or inside in order to make them reflect the current state of the world. And you can kind of see an example of how that process flows in the state chart here. This is an example taken from some of the documentation that people have written about the deployment lifecycle. A deployment is one of the default Kubernetes primitives. It deploys a bunch of pods, and it does that by creating a replica set. The way this works is it's actually dealing with this 3 layers of state. It's having a job where it goes in and its job is to create a replica set if it doesn't exist. That's the progressing status. Once the progressing status progresses to the next step, it runs through a whole finite state machine. But that's a more complicated one that's built in. We're going to focus on building our own. And to build our own, we're going to need to keep track of something. We're going to need to keep track of state. Now, if you want to do something more complicated than just a really trivial example like I'm showing, you're going to need a custom resource. Because a custom resource is how you can have Kubernetes look after your data. Because once you start keeping track of where you are in this process of multiple steps, you're going to need somewhere to save that. And the thing is, your container can die at any time. You need to be state back into Kubernetes somehow in order to not have any issues if Kubernetes decides that no, your node is on a piece of failing hardware, all of this stuff is going to be terminated immediately, and you're halfway through running some kind of a loop. You need to be able to pick that back up, which is the purpose of these kinds of data stores. So you create a custom resource definition, which is usually abbreviated as a CRD, and then once you have that defined, you can then make an instance of it, a custom resource. And then that can be used to store all the data about your current state. So whether it's how long something's been running for, what step of a process it's in, what version something is, anything you want to actually use as part of building your controller or your operator, you put it in a custom resource and it's yours to control and nothing else will step on it. So, unless you want it to. And then you basically read that. You read that data in and you make decisions based on it. And so you build a little loop there, as you can see in the flowchart, that it basically takes that data, reads it, checks it, validates it, and reconciles the world to match. So if it's something like we show in a moment, it'll make more sense there. So before we dig in further, I have an opinion that makes some sense now rather than later. Kubernetes is complicated, and the majority of Kubernetes controllers are written in Go. All the official SDKs for the operators were Go up until very recently. They've recently added some Ansible and Helm material, but Helm is doing the whole thing in static YAML, which is really confusing in times. And Ansible kind of feels like a layer inversion problem to me when I tried to use it, so I didn't like using it. But the easy path is clearly Go, and they make it Go because all of Kubernetes is built in Go. But I don't like using Go, which is why I went to try and work out how I could do it in Python. And I'm not the only person who's made that choice. It's not a crazy choice. There are plenty of people who've done it. One of the libraries that we're about to talk about was started inside of a company that chose not to. The Dask deployment tools use these libraries. It's not crazy. It's just a little off the beaten path. But depending on your specific use case, Python may not be the best choice. And if you don't like Go and Python doesn't fit, there are extra choices you can find out there. For instance, there's the Bonnie library, which from the Erlang and Elixir ecosystem does a really good job of letting you make these kinds of controllers and operators inside of Erlang and Elixir. And if you've never looked at Erlang and Elixir, I recommend it. They're good languages. But this is a talk about Python, so I'm going to get on with the Python library part. Starting off with the Kubernetes Operator Pythonic Framework, or Kopf, which was, as I said, started at Zalando in 2019. They actually were building that to deal with their own infrastructure. When the developer at Zalando left, he continued maintaining it, and that's been outside of Zalando's management. He's been maintaining that since 2020. That will make the operator part operate. You'd normally combine it with something like a PyCube library, where you'd be able to make your various API calls to Kubernetes after being told that something needs to change. And you may want to combine it with something like kubecrd, which helps make those custom resources. So those custom resources are absolutely without a question easier to do with this library. More than 10 times easier. This library is fantastic. And then there's another library here like KR8S, which I know I'm going to mispronounce at some point in the future. It is very cleanly designed. It's a more recent library written taking some of the lessons from all of the others. The author actually wrote a comparison blog post comparing his library and all of the other currently available ones. And it compares favorably. The documentation could do with more examples, but show me an open source project that can't deal with more examples and I'll be stunned. And all of this stuff tends to sit on top of Kubernetes APIs in the major official client library. There are a few rare ones that go direct, but for the most part, everyone just wraps the Kubernetes API client because it's available, it's up to date, and it's easy to get at. But it is a no-frills auto-generated library. This is the realm of the old Java doc sources where you just get big old class lists and function lists, and it's not the most helpful when you're trying to work out how to do something. It's very much a documentation of what is there, not a how to use, which is kind of a problem when you're trying to pick up and solve a problem and not learn all of Kubernetes, which is why the other libraries are probably worth using before you drop down to something lower level like this library. And I'm going to walk through using these because it's easy enough to start putting these pieces together, and it all makes more sense when you see the gears spinning together. And I'm going to start with a fairly simple operator. That is the entirety of that operator on one screen there. It has a very simple job. If a pod is too old, we will kill it, but only during certain times of day. So if you want to make sure that you don't accidentally kill stuff after hours, but you want to clean up after a memory leak that you know you need to deal with but don't have dev time to go and solve yet, you would possibly make something small and simple like this as a quick fix and maybe use it for a few months until the devs have time to go and fix the memory leak. So let's walk through what that whole section is with a little bit more readability. Let's have a look at what we're pulling in. So there's some basic Python imports there, async, JSON, logging. I'm using Pendulum for dates. Pendulum's a great date library. And then there's the Delta Man library, which does a really neat trick at parsing dates partially, but as time. So there's a few good libraries out there like Date Parser, but they're dates. I wanted a time. So I can now actually get like a time object out for a time comparison. So 8 a.m. to 8 p.m. or 5 p.m. till 7 p.m. and actually get that window in the middle, not as a date specified to a specific day, which is useful when you kind of want to do business hours math during single days. Using Dynaconf for settings, so I'm just pulling all these out from environment variables. Dynaconf is great. Some of you probably used it in various projects over the years. It's very popular. And this one is going to be using the PyCube library. So PyCube is being used to reference our pod. So we're going to get the pod data for those pod objects, and Kopf is being pulled in here. And that there is just a little last one where I've wrapped the Kubernetes API so that it works with my local Docker and all of that. And so we'll do some setup. We'll set up the logging. We'll pull in these environment variables. So we've got a sleep interval. Since this is going to be asynchronous, we want it to go to sleep when it's done. We're pulling in a target filter. So that will tell us which pods should be selected and operated on. We're going to have a configuration notation so we can find out what we're supposed to do, because we've got to stash some information somewhere here about how old we're allowed to let it get and when we're allowed to kill it. So we're going to have to tell this software where that's getting stashed. And that environment variable is just going to specify a Kubernetes annotation name. And the finalizer name is the bit you see down below there, which is Kubernetes has a concept called a finalizer. And it attaches these on all of these stuff when you make a controller. And a controller needs to be told, yes or no, these resources are dying. So when you have custom code running and Kubernetes goes, I'm getting rid of this, well, you need to know about it, because if you've gone and updated a DNS zone file or a security filter rule, or need to send emails off to notify a sysadmin somewhere, or whatever you're trying to do, you need to know about that before it's done so that you can actually actively do a thing that may need to take place before the deletion is complete. And that's why it will block, unless the name is unique. Because unless you've got a unique name, you might accidentally have two things waiting on the same thing, and Kubernetes will just go, neither of you are talking to me, sorry, and it'll just deadlock, and you'll just be sitting there with that pod going, I'm trying to delete, but I'm not going anywhere. So always give them a unique name. That's what the finalizer is there for. And Kopf makes it easy to just give everything a unique finalizer. And the operating hours is, again, an environment variable that will let us know when we're allowed to delete and not delete. So that function right there, that async function, is saying to Kopf, it wants to know about every pod that matches our filter. And every 60 seconds, we're going to go and get all the information about pods that match. So this function will get called once on each async thread for every pod that matches this list, be it 5, 10, 50, or 100,000. So it'll get fed that in and we'll have just as many threads as that. Now, that's not particularly efficient, which is why this is not the way you should probably build one. But it can work for small and simple things. If you only need to touch a handful of things and you want to get something built really simply, you don't need to make it more complicated than this. This is all it needs to be to actually make something useful. So as you can see in the document, as it goes through the while loop there, it's just going to load the JSON data out of that configuration. It just gets a dictionary string. It's just a little JSON string. We're going to get our max age out of that JSON. We're just going to pluck it out there. We're going to turn that into a time object we can work with. We're going to work out how many seconds that means. And then we're going to go, how old is the pod? And we're going to use Pendulum to read that string and go, it's this old. And then we're just going to make sure it's running before we go and try and delete something that's not running, because this library doesn't like deleting things that aren't running. And then we're going to go, is it older than we're allowing it to get? And then we're going to delete it if it fits. So when it runs through that, it's then going to actually get that pod out, and then it's going to pull that new reference out with that library. So if we tried to delete it from the body, Kopf wouldn't like it, because we've just deleted a reference to something that it's holding live. So we don't want to have them operating on the same thing. We want to have Kopf telling us data in and something else telling us data out. So that way they never step on each other's toes. So we're using that PyCube library to make a new request down there for a pod, asking for it by name, and then once we have it, we delete it. And then we just go to sleep. And that's the whole operator. That's doing what we were starting to set out to do. But it isn't particularly smart. If we run this against 100,000 pods, we're going to have 100,000 threads, 100,000 sets of memory, and 100,000 of these things waiting in the I/O loop. It's not ideal, which is why you'd normally structure it a little differently. And so this is the more appropriate way to structure one of these, which is using a CRD and separating things out a bit. So breaking through the 4 parts that I've broken that one up into, we start out with making the CRD. Like I said earlier, the Cube CRD library makes these really easy. That's sort of the start there. I'm importing a data class because that works with data classes. It's a data class driven library. You make a data class off that base class and all the magic happens. So I'm just pulling in that schema library to define some API schema stuff, because Kubernetes resources are defined with Open API schema validation, and that library takes care of that. And so what we have when we make our library like this is our little module now contains a custom resource definition we can make use of. So we're just saying it's going to have a name, because everything needs a name. It's going to have a maximum age, it's going to have operating hours, and it's going to have our target label, all in the custom resource definition. And then once we've got that defined, we can go and make ourselves a little script that's in a separate file, and then we can run that script to put one into Kubernetes. So we pull it in, we use the class method there for the install, and that actually tells the library to generate the full schema definition, the custom resource definition that Kubernetes needs, and install that into Kubernetes. It saves it into Kubernetes where it needs to live. And then once we've got it saved into Kubernetes where it needs to live, we can then make one. We can make an instance. And then we can go and make an instance of a class. We've got our demo config instance. We give it a name, demo config. We say 3 minutes. We say that it's going to run from 6 till 8. And then we're going to give it a name so that it can actually find which ones are valid to kill. We're just going to use that Kopf out of hours operator target true. Got to pick a name. And then we save that. And now that exists in the Kubernetes cluster. That has gone and made a custom resource for us, which we can now use to actually drive some logic. So let's encapsulate that logic properly. So we're going to have another module, and this module will have our config, our custom config here, which is using the KR8S library. Again, it's async, so I'm using the async imports, and it's going to pull that in from that other module. It's going to pull that in as our out-of-hours termination CRD, because when you use this, you can take a shortcut. Because we've already made the CR, we don't actually need to do all of that info again. I can just reference it all from the other one. So you see there where it's got the version, the kind, the singular, the plural, and the endpoint. I'm actually just grabbing them all from the other one I made. I could have made this all go away with some metaclass magic and never had to write them out myself. But I wanted to show what's actually going into one of these things rather than just hide it all away. Kubernetes is hard enough as it is without hiding what I'm doing behind the scenes. So once you've got your config started, you can make some methods on it. And so I've started by putting some properties on there to make things easier for myself later on. So I've got a little helper to automatically get me what my max age is in seconds. So it takes the human-friendly string, be it 6 hours or 12 days or whatever I pick, gives me seconds. And then I've got a little thing there that takes the labels that I pick and turns them into the appropriate string for this library to filter with, because this has a different filter format because libraries. And then I've got the start of my async functions. So you can see them there now. And I've got one that gets me my targets. So those target pods are the ones that I want to kill. And that async function will return those by making that API call. It's using the I knew I was going to do it, KR8S library to make a request to the pods endpoint and get me all the pods that match that label selector in that namespace. And once those have been returned as a list, I can then run that inside the last function, which you see there. So for all those pods in that function awaiting its return, love async, it's fun. I am going to go and get their age. And then once I have the age of it, I'll compare it to the maximum age. And if it doesn't meet the criteria, gone. And so that's all the logic encapsulated in this object attached to the custom resource. I didn't have to build that all into the operator. This is the custom resource doing the heavy lifting. And you can have multiple custom resources interacting with each other, keep their logic together the way you would have methods on like a Django controller or an SQL alchemy model, and have these things encapsulated cleanly and make it a bit easier for yourself when you go to build the working heavy lifting parts. And that comes to the last heavy lifting part, which is the actual logic that connects Kopf and that to the actual sections. So we're pulling in Kopf, we've got our logging again, we're again pulling a finalizer in because we've got to give it a unique name. We don't want them to step on each other's toes. And then we're going to have our function there where basically all we have to do is we just have to say, take the body of the outcome that Kopf has been triggered with. So here's the big blob that Kubernetes threw at us and said, hey, you asked me to tell you when this changed. Here you go. We throw that in. The custom resource definition is there going, hey, cool. And then what it does is every 60 seconds it gets thrown that object because that's the API. Kubernetes will periodically poll you if you ask it to. So every 60 seconds we get told, hey, is there anything to do with this? And all we'd have to do is go terminate old pods. That's all. The whole of that logic is encapsulated in us going and saying, take the current state, make our object, run the function. We don't have to do any logic here. We could have turned that into a one-liner if we wanted to. I split it over 3 to keep it more readable. And given that there's enough time left, I can actually demo it before the questions or during the questions because I know this is a fairly complicated topic. So there's probably a few questions that you might want to ask. So I'm happy to hear those, but I will also demo it through. Since, yeah, there is actually time to actually do that one. So let me just switch to mirroring and I'll show this actually killing some stuff. While I'm doing this, feel free to ask questions. Yeah. While I'm doing this, because this is going to take a minute.
In that last code snippet, you said that was called every 60 seconds by Kopf.
Yep.
But it was also, there was a while true loop. I'm just curious why.
Yeah, that's just to keep the async thread open. So it's going to get fed with the new data whenever it needs to, but it's just keeping that internal logic from getting completely dead off. And it works better with the async that way. There's probably a way to make it not need that, but I found it was slightly less memory hungry when I did it that way. I haven't bothered going into the actual AST and working out why. So I've got a Kubernetes cluster running here, and I'm just going to load that in.
Anyone else questions so we can make Sam multitask? Please phrase your question in the form of a question.
I'll do my best. When can we expect your book, please? No pressure.
I believe the video is available already. So I've just gone and made our little deployment there. So that's going to have made ourselves a bunch of Nginx containers you can see there. And then I'm going to run the little script that installs the CRD. So that's gone and installed the CRD there. That was that little middle script. And if you jump into here, you can see that I've now actually got a definition for a custom resource with all of its specification. And I've already got an example here, a fresh little one that was created a few seconds ago that says, here it is. It's going to run for 1 minute, demo config between 8 a.m. and 8 p.m. and 6 a.m. And it's got that little target there. And then what we can do is when we want to run that, we can actually just run the controller and run that here as the operator. And then that's just going to fire that up and that's going to run that there. And so that's now running in there. And since I think we haven't quite run out of time now that that's running, we should, hopefully before the end of the allotted time, see that kick in hopefully about the next 30 seconds or so and kill them. While I wait still more time for questions.
Need fun ways to visualize this stuff. The complexity of behind the scenes is astonishing.
Well, which is why I tried to leave as much time for questions, because it can be hard to see.
There's like a few check marks turn green and it's like, yeah.
What's the app that you're using there?
This is Lens. I'm currently running the open source build of it. Mirantis provide a paid for version, but it is just an Electron app that you can compile without all their junk if you don't want them nagging you for a subscription.
And it's a Kubernetes specific?
Yeah, it is a Kubernetes UI that allows you to sort of browse around and see all the various components. It has all these lovely features to sort of show everything sort of filtered by bits and pieces. It comes in handy once you start working in Kubernetes and kind of don't want to have to constantly use the command line to query every bit and read the JSON all the time. It is a handy tool once you're working with Kubernetes often.
That we do it that.
No pressure.
Oh, look, I can see that it's already not actually going to kill itself because I've obviously touched something during today while making notes for the presentation. So I'm not going to hunt for a typo right now, but when this would have run correctly, those three that you see here would have gotten killed and they would have been automatically restarted by Kubernetes with the same information. So that's what it would have killed there at the end there. And you can see the ones above it were killed last night while I was doing my last round of testing. So they were all sort of killed about 25 hours ago last time I ran this. So it does run through quite cleanly. It is all that you need to do a basic one. But when you start building a more complicated one, you'll need to start looking at how these pieces fit together. I do recommend diagramming one if you start trying to make one, because having the flow chart of what you want to have happen in front of you in some kind of documentation makes it a lot easier to think about. But it won't stop you making typos. Oh. Stu.
What are you missing out on by writing an operator in Python as opposed to Go?
Mainly the sort of all-box experience. The official SDK gives you a few nice helpers for doing things like generating your RBAC configuration that does authorization controls. So when you create a custom resource, you'd also normally specify some permissions to say these various things are allowed to call various APIs to change it. So you could restrict who can make the changes to these things. And there aren't really any helpers to do that in the Python world. That's one of the big bits that they have in the Go SDK that isn't in the Python one. But broadly speaking, all of the same functionality can be done with curl. So you're not really missing out on any functionality. It's just you're missing out on helpers to the functionality.
Chat time. Do we have one more question? Do you have one more thing you want to?
No, I'm just going off people's questions.
Oh, we'll make this the last question.
So yeah, I'm aware of operators for things like setting up Postgres and the terrible Kafka stuff, Zookeeper, things like that. Can you give us, with the benefit of your insight and working on this, any other use cases you might have for them? What sort of things can an operator do with a deployment of pods? What are options?
Like for instance, this library, the KR8S and Kopf are actually used by the Dask Kubernetes operator. So if you had a Dask deployment to do distributed processing of your machine learning or your whatever data science stuff you're using with Dask, you can actually have it look after a Dask cluster, and all of that gets handled with a operator written in this. So just like the Kubernetes ones to look after Postgres and the ones that you've seen, you can do very similar things with these Python ones. There's anything from security management on those mutator ones and the validator ones through to just basic things like this. At one point earlier this year, the first time I did any of these was actually like effectively just a quick hotfix, because Amazon had a library that they provided, but it was going to be 2 months until they released an update that fixed a tiny bug, and the bug was putting a label on a node. So it took about 30 minutes to write a little operator that watched every new node and just stuck the label on it. So effectively just I will fix it with a short shell script, but the Kubernetes equivalent. And you can go from things as small as that up to full management of data science pipelines with these. And it's a topic that's hard to cover the breadth of.
Cool thing.
Thank you. And I think with that, we will wrap up there.